To determine if this is linear or exponential in this particular table, you always want to do a quick glance and ensure that the x's are increasing or decreasing by the same amount, which they are. It's usually increasing by 1. So then we don't really have to look at the x's. We can exclusively look at the y's. If instead the x's were changing by a non-constant amount, something that's variable, then we'd have to take both into consideration, which is a little bit more complicated. But I like to look and see, what do I observe as far as what's occurring on the y's? It's definitely decreasing. Is it doing so at what appears to be a constant amount, or does it seem to be doing it more rapidly? Well, it looks like initially it's decreasing by 50, right? And obviously you can use your calculator to figure out that that changes by 50. But does it appear to be consistently decreasing by 50? Well, especially once we get to 45 and 27, I would say no. So I'm leaning much more toward an exponential model. And that means I could eliminate options A and B because those were linear. As far as the exponential model goes, we can actually make this pretty easy on ourselves. If we go to our program, you don't need to, but if you wanted to, you could go to, I would go alpha cosine to get right to the f's. If we go to function and we go to exponential, which is the third one, we see the exponential model is y equals a times b to the x, where a is the y-intercept, which occurs when x is 0. So the y-intercept's 125, which definitely makes the answer D. And notice, because they both have the same ratio, which is obtained by taking any y and dividing it by the one before it. So we could get that as well, but in this case, that wouldn't have helped us to narrow it down. The y-intercept did the trick, and again, the correct answer is D.